Hello, in this video we are talking about section 8.2 on series. Now we have talked about the connection between a series, so we have a sum from n equals 1 to infinity of a sub n, and the sequence of partial sums that is generated by this series. So we have s sub 1 is just equal to a sub 1, s sub 2 is equal to a sub 1 plus a sub 2, s sub 3 is a sub 1 plus a sub 2 plus a sub 3. So we're taking partial sums of our series, adding those values up, and those are the values that we're getting from our sequence, or for the sequence of partial sums. Now the reason why we need to talk about these two things is that a series converges if and only if the sequence of partial sums converges. And in fact, whatever the sequence of partial sums approaches is also the value of the series. So to determine if the series in example 1 converges or diverges, we are going to look at the sequence of partial sums. So the series that we have in this example is the sum from k equals 1 to infinity of negative 1 to the n plus 1, and I'm sorry, that's a typo. It doesn't really matter what letter is used for the index, but it should be consistent. So this could say either the sum from n equals 1 to infinity of negative 1 to the n plus 1, or it could equivalently say the sum from k equals 1 to infinity of negative 1 to the k plus 1. But you shouldn't have mixed letters for the index, okay? So I'm going to go ahead and go with this formula that's written in terms of n. So for s sub n, our sequence of partial sums, s sub 1 is a sub 1, so that is the first term in our series. So that would be when n equals 1. So we're going to have negative 1 squared, which is a positive 1. Now s sub 2 is a sub 1 plus a sub 2. So notice that's the same thing as our previous sequence value plus the next term. So that's going to be 1 plus, now we'll have negative 1 to the 2 plus 1, so that's negative 1 cubed, which will be negative 1. 1 plus a negative 1 will give us a 0. Then s sub 3 is going to be a sub 1 plus a sub 2 plus a sub 3, and notice this is the same thing as our previous term in the sequence, plus one more term in the series. So that's going to be 0 plus negative 1 to the 3 plus 1, or negative 1 to the 4th, which will be a positive 1. So we're going to get 0 plus 1, or 1. S sub 4, continuing our pattern, is going to be s sub 3 plus the next term in the series, so that's a sub 4. So this is 1 plus negative 1 to the 4 plus 1. That's going to be negative 1 to the 5th, so negative 1 plus 1 will end up giving us a 0. So I think it's pretty easy to see what the pattern in the sequence is now. The first term is 1, then 0, then 1, then 0, and so on and so forth. So our sequence of partial sums looks like a sequence of alternating between 1 and 0. 1, 0, 1, 0, 1, 0, and so on and so forth. So if we look at the limit as n goes to infinity of s sub n, there's no way that this limit can exist, because as n goes to infinity, or as we increase our number in these terms, we're always just going to be switching between 1 and 0. So this limit does not exist, and that is because the terms alternate indefinitely between 0 and 1. Now, because of the fact that a series converges if and only if the sequence converges, since it's if and only if, it means that if the sequence diverges, then the series diverges as well. So this means that the sum from n equals 1 to infinity of -1 to the n plus 1 diverges because the sequence of partial sums diverges. And there is our final answer for example 1.